Hey guys, so our objective here is to be able to graph horizontal and vertical lines. And so if you look at our, our normal x and y axis system that we have here, or x and f of x, which is the same thing as y, graph, we kind of know how to graph normal lines already. We know that we've got f of x is equal to mx plus b, where b is the y-intercept, m is the slope. We know how to put in inputs and get outputs to graph. But the one thing we really haven't looked at very well, or really much at all, is what is the equation of a horizontal line or the equation of a vertical line, and how does that affect slope, and what are the slopes of those things? So that's what I want to talk about. And let's start with horizontal. So horizontally speaking, if we had, I'll just draw, I guess, a horizontal line here. And what I guess we want to notice is that a horizontal line has an infinite amount of x's. So it's, this x value, 1, 2, 3, 4, 5, all the way into positive infinity, negative 1, 2, 3, all the way into negative infinity. The x values can be anything, but the y values are stuck. And in this particular case, it looks like I've made the y values 2, if I can get that drawn correctly. So this line never strays from an f of x value of 2. F of x always stays 2, but the x's change. So if we were going to calculate the slope, rise over run, we would choose 2 points off the graph. So this is the point 1, 2. And I'll choose this point right here. I'll just go over a little bit. This is the point 3, 2. Notice what happens if we put these into the slope formula. If you remember, that's y2 minus y1 over x2 minus x1, which is just the change in y over the change in x. It's kind of a complicated way of saying that. So if I plug in these points, I'm going to make this point 2 and this point 1. I'll go, okay, 2 minus 2, you might see this already, and 3 minus 1. I'm going to get 0 over 2. Well, 0 divided by anything is 0. So the slope of this flat line is 0. And what happens if we plug in 0 for our slope? Well, we'll get f of x is equal to 0x plus b. Or f of x is just equal to b. Now remember, b is the y-intercept. Where does this thing go through the y-axis? Well, it goes through the y-axis at 2. So the equation of this line must be f of x is equal to 2. Or if you don't like f of x and you're using y's, y is equal to 2. And it's equal to 2 because it can never stray from that. It's always equal to 2. The y value is always equal to 2. Now, we just kind of know that if the y value is always equal to 2, then the x value could be anything we wanted it to be. You could have negative a trillion x way down over here, and it's still going to have a y value of 2. And because of that, this is the way we express that. And so I'm going to give you a few equations, and this is also, let me write it over here too, f of x equals 2. For your homework, I'm going to give you a few horizontal equations and ask you to graph those horizontally. So I might say, can you graph f of x is equal to negative 5? All you would do is you go down 5, 1, 2, 3, 4, 5, and you draw a horizontal line. It's that easy. Horizontal lines are easy because the slope is 0, as evidenced by the slope formula. Okay, let's look at vertical lines. All right, guys, so now we're going to look at vertical lines. So that's what we're doing, vertical lines. And there are some similarities to horizontal lines, but there's some differences as well. So let's go ahead and start by drawing a vertical line. See if I can do that somewhat neatly. Oh, I missed barely. Pretend this is right at negative 2, okay? I'll cheat and make that line a little bit thicker. So this is similar to horizontal because now, instead of the y's being the same, the x value always stays the same. Any point on this line, you could pick any point you want. Point here, a point here. This is negative 2, 2. This is negative 2, 1. Right here. That's that fact that this negative 2 is here, that's going to be there forever, all the way to positive y infinity and negative y infinity, or f of x infinity. Then we'll label this f of x, and I'll start trying to use f of x exclusively, and this is x. All right, so what happens? How will we do an equation? Well, it's actually quite simple. Because x is always -2, the equation is x equals -2. That's pretty simple, right? That's actually the answer to this. If I was to ask you, give you a line and say, hey, what's the equation? X is -2 for a vertical line is your answer. So vertical lines, x will always equal some number. Okay? But let's dig a little deeper and try to understand why. Let's attempt to calculate the slope, because if we look at our function, f of x equals mx plus b, remember, this only works for linear functions. But this is not a function. This fails the vertical line test. And it's got multiple outputs for a single input. I put in -2, -2, but I got 2 different outputs. In fact, there's an infinite number of outputs for the input of -2. So this is useless because we're not dealing with a linear function. In fact, vertical lines are the only kind of line I know that aren't functions. So let's calculate the slope real quick. We know it's y2 minus y1 over x2 minus x1. I'll make this point 1 and this point 2, okay? That point 2. So let me plug that in. So that's y minus 2, or excuse me, 1 minus 2 over -2 minus -2. And you might see already what's happening here. Oops, sorry, this thing's not drawn very well. Hopefully it is legible. We get -1 over 0 because -2 plus 2 is 0. So over 0, and we are not allowed to divide by 0. So the slope is said to be undefined of a vertical line. Because think, we have absolutely no run. We only have rise. So there's only a rise, no run. The run 0, so the slope is undefined because we cannot divide by 0. So that's another reason that function is, just won't work for us. So the equation to this is real simple. X equals -2. It's not a function, and good luck on solving those problems on the website. If you have any questions, email me. All right, see you guys later. Thanks, bye.